Welcome back to CTV. In this video, we are going to focus on 2NF. Before you come to 2NF, I really recommend you to watch the videos on normalization and 1NF because we will be using the idea of 1NF here multiple times. So, yeah, please watch 1NF and come back to 2NF. Yeah, let's dive right in. 2NF, second normalization form of relation. Okay. So first of all, we'll talk about the characteristics. We'll just dive right in. So first of all, let's talk about characteristics, the key characteristics. Well, the key characteristics is we can talk it in two perspectives. Okay. We can talk it in two perspectives. So the first perspective is all the non-prime attributes. All the non-prime attributes. What are non-prime attributes? Good question. Non-prime attributes. Non-prime attributes. Non-prime attributes are attributes which are not part of any candidate key. Any candidate key. Okay. It is not part of any candidate key. Then only we call that as non-prime attribute. We know the candidate key. Candidate key. So we know candidate keys are superkeys which can be used to identify a tuple in a relation uniquely. At the same time, that superkey must not have a proper set which is also a superkey. That's what we call candidate keys. And these candidate keys, from these candidate keys only, we will select the primary key, and other candidate keys will be named as alternate keys. So, non-prime attributes are any attribute that is not part of any candidate keys. Now, let's speak about the characteristics. All the non-prime attributes should be fully functionally dependent on primary key. All non-prime attributes, all non-prime attributes should be fully functionally determined, fully functionally dependent, fully functionally dependent, fully functionally dependent on primary key of the relation. This is the main and important one we are going to talk about throughout this lesson. This is the main thing that we are going to talk about throughout the lesson. Okay. So now you may ask, what's the second perspective? Well, if no non-prime attributes, if no non-prime attributes are partially dependent on, are partially functionally dependent on pk of the relation, primary key of the relation. So the same thing, but we are seeing in different perspectives. Either you can check it by this. You can check the second normalization form of a relation by checking the partial functional dependency, or you can check the fully functional dependency to make sure whether the relation is 2NF or 1NF. That's your call. That's your call. Okay. So let's say, okay, if something is not in 2NF, if something is not in 2NF, it should look like this. Let's say there is a table called student, and that has the attributes student ID, comma, stud name, comma, instead of ent, I'll also erase that. Okay, and do that. Stud ID, stud name, and we have course ID, course name, comma, grade. Okay. Well, we don't need course name. Okay, if there was course name, it's not even in first index. So we'll just have this. Okay. Now we can say stud ID and course ID are the primary key. Now we can say stud ID functionally determines stud name, isn't it? Yes. We also know that stud ID, comma course ID functionally determine grade. Stud ID, comma course ID functionally determine grade. These are the two functional dependencies that you can arrive here. But here you can see stud ID only functionally determines stud name, which means stud name is not dependent on course ID, primary key. It is partially dependent on the primary key, partially functionally dependent on primary key. Why? Only stud ID functionally determines stud name. That's the issue here. In 2NF, we are going to solve that. In 2NF, we are going to solve that. So, before we solve everything like that, let's talk about the practical rule so that we don't forget these things. The importance of learning facts first. Okay, everywhere. Okay, whether you go to any, you can try any of the courses. Okay, any of the courses in your life. But whatever the course is, there will be two things. One will be facts, and then you will have calculation part. Mostly everything will have this, or calculation or application part. Okay. If you can apply everything properly, if you want to apply everything properly or calculate everything properly, you should be clear with the facts. I know this is the boring part. This is the boring part. Obviously, no one wants to know facts. We need calculation parts. Yeah. But I'm just saying you, if you don't understand the boring part, if you don't finish the boring part, the interesting part will become tedious. So always keep in mind, you need the facts to apply in the future. So keep that in mind. Right? Always keep that in mind. Now we'll get back to our important studies. So practical rule is we have to eliminate redundant data. And so how can we eliminate redundant data? Eliminate redundant data. That's what we are focusing here. In 1NF, what did we focus? In 1NF, what was the practical rule? Yeah, we have to eliminate the repeating rule. We have to eliminate the repeating rule. Now here, we are eliminating redundant data. So, what did we study earlier? We studied that if a non-prime attribute is partially functionally dependent on the composite primary key, we can say the relation is not in 2NF. So, what we have to do is, we have to separate that attribute and place it in a new relation. That's all. Okay. Find that attribute and place it in a new relation. Which attribute? Non-prime attribute that is partially functionally dependent. Attribute that is partially functionally dependent. I know this is recurring again and again. I don't have any other words for that. I can say FD. Yeah, I'll say FD hereafter. You can understand, right? Partially functionally dependent on composite primary key. So this is another indicator. If you have a singular primary key, well, that is directly in 2NF. Because only if you have composite primary key only, you can say any non-prime attribute can be partially dependent on the primary key. If you have a single primary key, well, then that is settled. The relation is already in 2NF. Okay, partially functionally depend on composite primary key. Okay, this prime, find this attribute, find that attribute, and place it in a new relation. Find that attribute and place it in a new relation. Place it in a new relation. I think you can understand this. So the formal definition, this is important because this is how you have to justify formal definition. Why do you need this? This is how you will justify a table is in 2NF or not. Okay, the formal definition is first part is the relation is already in 1NF. If the relation is not in 1NF, well, then you can't do set 2NF. You have to first make it 1NF. Okay. So the relation is already in 1NF. And the second one, we have to make sure there is no partial functional dependency. So all non-prime attributes are fully functionally dependent, I will say FD, on PK of relation. This is the formal definition. If these two conditions are met, you can say the relation is in 2NF. Alright. So let's get back to that example I was talking about. Student relation. That's stud ID, course ID, stud name, and finally grade. These two were together primary keys. So I will break this down. Since stud ID functionally determines stud name, I will put that in separate. Student stud ID, comma stud name. And here the primary key will be stud ID. And we can say this is fully functionally dependent on stud ID, the non-prime attribute. Here I will use stud course table in other relation. And that will have stud ID, course ID, and grade. Course ID and grade. Now we know the grade, non-prime attribute grade, fully functionally dependent on stud ID and course ID. Okay, so this is one way to do this question. All right, and this is the best way to do this question. If you have any other ways, obviously try them, but I'm not wasting time on that. Now let's say we have something like this, some relation like this, prof relation that has prof ID, a prof name, test ID, test name, depart course ID, course name, or course location. Okay, this is course location. Consider this as a single valued attribute or an atomic attribute. Okay, consider this as an atomic attribute, not multi-valued attribute. Okay, now we have prof ID, depth ID, and course ID as a primary key. Why? Then only department name can work. The course hours, that is very important. That is dependent on course ID and prof ID, but not. So we have these specific attributes, and let's say they have given us prof ID, okay, prof ID and course ID functionally determines ours. So that is the first functional dependency they have given us. Okay, in this case they are giving the functional ID. Okay, the functional dependencies. Okay, this is FD1. You may think from the last video in 1NF, I told that we should remove the nested relations. Okay, but keep in mind here these are not composite attributes. Okay, these are not composite attributes. These are not composite attributes. So they are actually in single attribute. The atomicity is maintained. Okay, so they are giving that it is already in 1NF. Okay, now we have to convert it into 2NF. That's the question here. All right. So they have given us prof ID and course ID functionally determines ours. Okay, and department ID functionally determines department name. That is another FD. Okay, that is another FD. Prof ID functionally determines prof name. That is another FD. Okay, prof ID functionally determines prof name, and course ID functionally determines course name and course location. That is FD4. These are the four FDs they have given us. All right, but the primary key they are saying that prof ID, depth ID, and course ID altogether it is the primary key. Well, here we can clearly see. Prof name is partially dependent on the primary key. Why? We know the primary key is given as prof ID, okay, prof ID, comma, dept ID, comma, course ID. Let's say this is a set of attributes X. Okay, let's say this is a set of attributes X. Well, here X is the primary key. X is the primary key. That's what they are saying. X is the primary key. That's what they are saying. But we know this is not in 2NF. Why? A non-prime key attribute, a non-prime attribute, prof name, is partially dependent on the primary key. Partially. Why is it partially dependent? Well, it only depends on prof ID. And department name only depends on department ID. Course name and course location only depends on course ID. And ours functionally dependent on only prof ID and course ID. Therefore, we have to change this. We have to decompose this table. We have to normalize this table. So what I'm going to do is, I'll break this into mainly 1, 2, 3, and then 4, 5. I'm going to break this into 5 tables. The first one will be, no, 4 tables is enough, yeah? Yeah, 4 tables is enough. First one is prof table. In prof table, I will have prof ID and prof name, yeah, and also department ID. I also have department ID. Why am I doing this? Why am I including department ID in this already? Well, think about this. Okay, well, think about it. Why? Well, I can actually add course ID too. But if I include course ID, there will be an issue. Yeah, we don't have to include course ID. So, prof ID functionally determines prof name. And prof ID, we know they have not given it. Yeah, they have not given it that prof ID functionally determines dept ID. Yeah, this is also has to be true. This is also, let's say, they have given us. Why? Because a professor can work in only one department, and that depends on their professor ID. Okay, let's say there is a professor called John, and he only works in a department. For example, IT department. Okay, he only works in IT department. And how is that concluded? Well, it is concluded by his ID. Okay, let's say he has a ID prof 0057861. Okay, wait, 5786 is not there. Well, that's also high. Let's say 578. Okay, let's say that is 578. So, Professor ID 578 is John's ID, and that determines which department he works. Okay, so we can actually include that in one relation. Then I will have department relation, where I will have department ID as well as department name. Okay, department name. So there are so many mistakes. Here it should be department. Here it should be department. Here it should be department. Okay. Now the third one will be course ID. Okay, the third one will be course relation. Okay, course relation. In course relation, I will have course ID and also course name. Very well. Okay, very well. Now finally I have prof course relation. Prof course relation. Why do I have prof course relation? Because prof ID, comma course ID functionally determines prof ID, course ID functionally determines the hours the person is putting in. Okay. Here one small change should be made. We should not stuck with course name. We have to also add course location. Okay. We have to also add course location. Okay. So in this specific university, the thing is every course is conducted in a specific place. Okay, that's how you have to think. Or else the proper functional dependency would prof ID, course ID, functionally determines course location will make sense. But in this case, they are saying course ID functionally determines course location. Keep that in mind. Well, here everything is done. Okay, we have the functional dependency. Which one? We have the functional dependency. We have the functional dependency 1 and we have the functional dependency 3 and 5 satisfied in the first relation, and the second one, FT2, is satisfied in the second relation. FT4 is satisfied in the third relation, and FD1 is satisfied in the fourth relation. So all the FTs are saved. The lossless joint property is achievable. Okay, the lossless joint property is achievable. So this is how you have to tackle this specific question. We'll do another question. Okay, so we have vendor inventory. We have vendor inventory, and that relation has vendor ID. I'm giving you examples of really bad schemas and making them the best schemas there could be from them. Okay, so keep that in mind. And then we have, well, vendor ID. Yeah, then we'll keep it as Win ID. Yeah, that's better. Win ID is better. Win ID, Win name, and we can have product ID, and we can have product name. We can also have product price, and we can have quantity. So here you may say, I know this Win ID and product ID, they both are required to find this thing. So you can say, if we decompose this into like this, okay, like vendor, and we can have Win ID, product ID, not product ID, Win ID and Win name. All right, you can say Win name, and the Win ID will be the primary key, and we can have inventory. Well, not inventory, product. Okay, we can have product, and you can see that is product ID, product name, product price, because product price, you can say it depends on product ID, yeah, and you can say it depends on quantity. Quantity also depends on product ID. You can say like that. And finally, you can have vendor inventory. There we will just join which vendor provides which product. So you can have Win ID and product ID. See, this creates an illusion that you're correct. If you write like this, you may think this is correct. This depicts everything. But the problem here is it is not right. It is not right. Why? See, you said product price and quantity are fully functionally dependent on only product ID. The truth to be told, it's not. Okay. You can buy the same product from different companies at different prices, and you can have stock. Okay. You can have the quantity differently based on the vendor. Okay. Let's say there is a vendor X and let's say there is a vendor Y. These both can provide you pencil to your company. And let's say the quantity of the price of pencil by X company is 20 rupee and the price of pencil by Y is 30 rupee. Well, that will create an issue. That will create an issue. If you give product ID 1, product name pencil, what will you give as price? Will it be 20 or 30? And quantity, let's say you have 15 remaining of this and 17 remaining of this. What will you give, 15 or 70? Now we understand the issue. It may look like it's correct. It doesn't always have to be correct. Okay. So a little mostly you can find this by the relational instance they give you. Sometimes they will give you relational instance. Okay. And if they don't, I'm really sorry to say this. Please use your common sense. Please use your common sense. Okay. So product price and quantity won't come here. They will come here instead. Product price and quantity. Product price and quantity. And this is the final example that we are going to look at. If you have any doubts, please let me know. No worries. Maybe in a future video, I will explain that to you. All right. So that's all about 2NF. Just remember, in 1NF, you will eliminate repeating groups. Eliminate repeating groups. Eliminate repeating groups. What do I mean by that? No multivalued attributes, no multivalued attributes, and no composite attributes. or any combinations of those. And 2NF, eliminate partial functional dependency. Eliminate partial functional dependency. Or you can say eliminate redundant data. That's all. All right. So in the next video, we will be focusing on 3NF. Okay. Before you come to the next class, okay, before you watch the next video, please make sure that you learn about this thing, transitive dependency and come. Okay. Learn about transitive dependency and come. It's one of the functional dependencies. Learn about that and come. All right. I will meet in the next video. Thanks for watching the 16th video in our normalization series. If you found this breakdown of second normal form helpful, don't forget to like, share, and subscribe for more database tutorials. Hit the bell icon to stay updated with our latest videos. Yeah, I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.